Hi, it's Miss House. I want to work through the 3.3 homework problems so that these will help you when you get ready to do your homework. So the first example is find the average rate of change for the function f of x equals x squared plus 12x between x equals 0 and x equals 5. So the important thing to know here is that the average rate of change is the same as the slope formula. Except we're not dealing with a line, we're dealing with a function. So we write our average rate of change formula, the AROC formula as I like to call it, by saying the second y minus the first y over the second x minus the first x. So basically, because we don't have a line anymore, we have a curve. We call the first x A, the second x B. So this is f of A and f of B. So it's still y2 minus y1 over x2 minus x1, only it's in this function notation format. So the first thing I have to do is I have to find f of B, so that's f of 5, okay, minus f of 0 divided by 5 minus 0. So f of 5 means what you get when you put a 5 into the original function. So that's 5 squared plus 12 times 5. That's 25 plus 60. So that's going to be 85. So f of 5 is 85. Now f of 0 is going to be 0 squared plus 12 times 0. 0 plus 0 is just 0. So minus 0 divided by 5 minus 0. So my average rate of change is 85 divided by 5. And you just do that on your calculator and you get 17. So the average rate of change between those 2 points is 17 between 0 and 5. Now number 2, similar kind of problem. We have this time f of x is x squared plus 11x between x is 0 and x is 4. So I'll go ahead and find f of 4, that's my second x, is going to be 4 squared plus 11 times 4. 16 plus 44 is 60. F of 0 is going to be 0 again because it's 0 squared plus 11 times 0 is 0. So my average rate of change is going to be 60 minus 0 over 4 minus 0. 60 divided by 4 is 15. In number 3, they give us a square root function. Y equals the square root of 5x plus 1. And they don't use the function notation, but they could. F of x is the square root of 5x plus 1. Because both of these, y and f of x, mean what is the output for a given input of x. This time, it's between x equals 7 and x equals 16. So I'm going to find f at 16 is the square root of 5 times 16 plus 1. That's the square root of 80 plus 1. The square root of 81 is 9. And then f of 0, be careful, it's not 0 this time. The square root of 5 times 0 plus 1 is the square root of 0 plus 1. The square root of 1 is 1. So my average rate of change is 9 minus 1 over 16 minus 7. That's y number 2 minus y number 1 over x number 2 minus x number 1. So that gives me 8 over 9, and that's my average rate of change. And that's number 3. Number 4 involves a function using e. And e, like pi, is a dedicated letter for a specific constant. It's pretty close to 2.71818. If you do it on your calculator, you press second and the natural log key. 2.718, sorry, that's a 28. 71828. Okay, so that's to 5 decimal places, and that's enough places. Okay, and we're going to use this decimal in just a few minutes. So for this one, they want x to move from -4 to -1. Now, remember that when you're in negative number land, -4, -3, -2, -1, that this would be the first x and this would be the second x, okay? Or this would be a and this would be b. So we need to do the -1 first and then the -4. So let's write this. F of x equals e to the x. So I need to do f of -1. That's going to be e to the -1, which is also 1 over e. But you can do this, either one of these, on your calculator. Okay? F of -4 would be e to the -4, and again, negative exponent, 1 over e to the 4th. Okay? Now, when I do my average rate of change, I have 1 over e minus 1 over e to the 4th over, now remember, it's -1 is my second x, subtract -4, my first x, so it's going to be 1 over e minus 1 over e to the 4th divided by -1 plus 4. Okay, so that's 1 over e minus 1 over e to the 4th. -1 plus 4 is going to give me a 3 denominator. Okay. Now, we could simplify this complex fraction by multiplying everybody by e to the 4th if they ask us for an exact answer. So that's going to give me e to the 3rd minus 1 over 3 e to the 4th. This is actually easier to enter in the calculator than this 1 over e stuff. But look, we can do it this way. 1 over e, because they don't ask for the answer in terms of e, they ask for a decimal, let's see, to 4 places. So we need a 4-place decimal. Now, if you need a 4-place decimal, you better go 5 or 6 places here. so that when you round, you get it right. Okay, and you can just use the E key. So I'm going to do 1 divided by second natural log to the first is 0.367879. Okay, so I did 1 divided by second natural log. That pops up e to the parentheses, and plain e is e to the 1. So I had to type a 1 in there or the calculator won't take it. Okay, and that gave me this first decimal. Then I need to do 1 over e to the 4th. Okay, so that's going to be 1 divided by second natural log, and then a 4, and that's going to be 0.018316. Okay, now I'm supposed to subtract these two numbers, so 0.367879 minus 0.018316, and that's 0.349563. Now I'm not finished yet because I have to divide that. Remember, here it is. This is the format I'm doing it in. This denominator's 3, so I have to divide it by 3. So this divided by 3 gives me my answer, 0.349563 divided by 3 is 0.116521. 4 decimal places, 1, 2, 3, 4. This 2 says just knock this stuff off. 0.1165 is my average rate of change. I'm sorry, yeah, average rate of change. Yeah, it's my average rate of change. All right. Now on the next two problems, they ask us to do, or the next few problems, they ask us to do instantaneous rate of change, okay, or instantaneous velocity. So, oops, we have instantaneous rate of change. Okay, now there's a video in the first day's module about instantaneous versus average rate of change, and you need to watch that because I use an applet to show you what we're actually doing. But remember, when we did average rate of change, all we were doing is finding the slope between 2 points on a curve. So it's just a line, okay, and it's between any 2 points. But on instantaneous rate of change, I might just want to know the slope right here at this original point. Okay? And so what I have to do is I have to take this point and move it back, and I end up with 1 point right here. Okay? So I'm doing the slope of this line back here. Okay? That's at an instant, how is the curve changing? Between here and here, it's its average. Here, at this only one dot, it's instantaneous. Now, what we learned is it's still the slope formula, okay? But it's the limit as h goes to 0. Because remember, h is the distance between these points. And I'm backing up that first point till that distance between them is just 2, and I'm right here on only this point because the distance between them has gone to 0. So that's where the limit as h goes to 0 comes from. F of x plus h, well, that's the second x. If this is at x and this is h over, that's at x plus h, minus the function at the first, okay, divided by h. And where does h come from? Well, it's the second x minus the first x. Well, the x's cancel out, and I just get a h. Now you can see our dilemma here because as h goes to 0, you got a 0 denominator, but it's going to work itself out through the algebra as you do the actual algebra of finding this. So they give us a function of, and we're probably going to need a lot more space, but let's just go ahead and get started on this page. S of t is 5t squared plus 3t plus 2. All right? So I've got to find the value of the function at t plus h or x plus h. All those t's could be x's, so it doesn't really matter. So I have s of t plus h is going to be 5 times t plus h squared, because every time I have a t, I'm putting in t plus h, plus 3 times t plus h plus 2. Now, t plus h squared, let's talk about that. That's a binomial, and to square it, you have to write it out twice and use the full rule. F O I L. First, outside, inside, last. So that turns out to be t squared plus th or ht plus th or ht plus h squared. So look, this gets doubled up. T squared plus 2th plus ht. It's not t squared plus h squared, okay? Be careful. That's an easy pitfall to fall into. So I'm going to go back over here, and this is going to be 5 times t squared plus 2th plus h squared. Then I have to multiply this 3 times both of these, 3t plus 3h plus 2. And then finally, I've got to multiply that 5 all the way through there, so 5t squared plus 10th plus 5h squared, and then plus 3t plus 3h plus 2. So it's a really long expression, and there are no like terms. Okay, and all I've done is this first part, the function at the x value plus h. So we had a t instead of an x, so at t plus h. Now look what this formula says. It says take away the original function. So everything in here I have to subtract from this one. So I've got to subtract a 5t squared. I'm going to line it up under the other 5t squared. I'm going to subtract a 3t. I'm going to line it up, and I'm subtract a 2. Well, it's not a coincidence that these are going to all go away, because this is what it says. It says find this function and then get rid of everything that was from the original function. So the 5t squared was original, the 3t was original, and the 2 was original. And that leaves me with a 10th plus 5ht plus 3h. Okay, I'm not done though, because look, what does the formula say? Divide by h. Okay, I haven't done my limit yet. I'm still trying to do all this algebra. I got to divide by h. Well, look, there's 3 things. I have to divide them all by h. So divide that by h, divide that by h, divide that by h. I end up with 10t plus 5h plus 3. Now I'm ready to do my limit. So it's the limit as h goes to 0 of 10t plus 5h plus 3. Now, when you're doing a limit, you can substitute unless you have a 0 denominator, which you can't substitute into that. The square root of a negative, you can't substitute something that makes that, or the log of a negative or 0. So if it's not one of these three problem areas, you can just do substitution. So this is going to be 10t plus 5 times 0 plus 3. So that's 10t plus 3. Now, they ask us to do it when t is 2. So when t is 2, that's going to become 10 times 2 plus 3, which is 23. So that's the instantaneous rate of change to this function when time is 2. So at that exact time, it's changing by going up by 23, because that's a positive 23. So it's going up by 23. All right, let's do one more of those. Okay, so number 7, that was number 6, says we have s of t, and it's 5t squared. Subtract 5t, subtract 9. It's going to be very similar, except we got these subtractions in here, and that's going to make it just a little bit harder. So we got to do the limit. H goes to 0. S of t plus h minus s of t over h. So s of t plus h is going to be 5t squared plus 2ht plus h squared minus 5 times t plus h minus 9. So it's 5t squared plus 10ht or th, doesn't matter. I think I put th last time. Plus 5h squared minus 5t minus 5h minus 9. Okay, so that's s of t plus h. Now I'm going to subtract from that everything from the original. So I'm going to get rid of the 5t squared. I'm going to get rid of the negative 5t. So I'm going to subtract a negative 5t. That's going to be a plus 5t. And then that's going to be a plus 9. Because remember, I'm doing the negative of all of them. Or just think of it this way. Anything from the original function is gone. Okay? Because this says take away anything from the original function. So that gives me a 10th plus 5h squared minus 5h. And the last part of the formula says, hey, divide everybody by h. So h here, h here, h here. The h's are going to divide out here. Here, I'm going to be left with an h on top, and here they divide out completely. So it's 10t plus 5h minus 5. And now I can do the limit as h goes to 0 of 10t plus 5h minus 5, and I get 10t plus 5 times 0, because I'm plugging in 10t minus 5. That's the formula for the instantaneous rate of change, and they asked me to do it again when t is 2. So that's going to be 10 times 2 minus 5. 20 minus 5 is 15.